As a species, we tend to be very good at solving problems, but not so good at predicting them. We need to recognize the potential consequences of what we are creating before we create it. Tim Cook. History of Deep Learning from Perceptrons to ChatGPT. Deep learning has revolutionized the field of artificial intelligence by enabling machines to learn and improve from experience in a previously impossible way. In this article, we will explore the history of deep learning, from its earliest roots to its current state-of-the-art implementations, including the latest breakthrough ChatGPT. Perceptrons. The earliest neural network model was the perceptron, developed by Frank Rosenblatt in 1957. The perceptron was a single-layer neural network that could learn simple patterns by adjusting weights in response to input data. However, it needed to be improved in its ability to model more complex patterns. Backpropagation. The backpropagation algorithm, developed in the 1980s, enabled the training of multi-layer neural networks. Backpropagation is a method for training neural networks by adjusting the weights in the network to minimize the error between the predicted output and the actual output. Multi-layer perceptrons. In the 1980s, researchers began to explore the idea of using multi-layer perceptrons, MLPs, to model more complex patterns. MLPs are neural networks with multiple neuron layers between the input and output layers. The additional layers allow the network to learn more complex patterns by combining simpler patterns from the previous layers. Deep belief networks. In the 1990s, researchers began to explore the idea of using deep belief networks, DBNs, to model complex patterns. DBNs are neural networks with multiple layers of hidden units trained to represent input data features. The layers are trained unsupervised, allowing the network to learn more abstract representations of the data. Convolutional neural networks. In the late 1990s and early 2000s, researchers began to explore the use of convolutional neural networks, CNNs, for image recognition tasks. CNNs are neural networks that are designed to process images and other multidimensional data. They use convolutional filters to identify features in the data, such as edges, corners, and other shapes, which are then used to make predictions or classifications. Recurrent neural networks. Another type of neural network that has played a vital role in developing deep learning is the recurrent neural network, RNN. RNNs are designed to process data sequences, such as text or speech, and are commonly used in natural language processing and speech recognition applications. RNNs use a series of internal memory cells to keep track of previous inputs and generate outputs based on that context. Deep reinforcement learning. In recent years, deep reinforcement learning, DRL, has emerged as a new area of research in deep learning. DRL combines deep neural networks with reinforcement learning, a type of machine learning in which an agent learns to interact with an environment to maximize a reward. DRL has been used to train agents that can play video games, control robots, and even drive cars. One of the most famous examples of DRL is AlphaGo, a computer program developed by Google DeepMind that defeated the world champion in the ancient Chinese game, Go. AlphaGo. AlphaGo made history in 2016 when it defeated Lee Sedol, one of the world's top players of the ancient Chinese game of Go, in a 5-game match. The victory was seen as a breakthrough in artificial intelligence and was hailed as a triumph of deep learning. AlphaGo used a combination of deep neural networks and Monte Carlo tree search to evaluate potential moves and make decisions. The neural networks were trained on millions of expert-level Go games, allowing AlphaGo to learn and recognize patterns in the game that would be difficult for human players. Transformer architecture. The transformer architecture was introduced in a 2017 paper by Vaswani et al. And represented a breakthrough in natural language processing. Transformers use a self-attention mechanism to learn contextual relationships between words in a sentence or sequence of terms. This allows them to capture long-range dependencies and create more accurate language models. BERT and GPT-2. In 2018, Google introduced the bidirectional encoder representations from Transformers, BERT, model, which achieved state-of-the-art performance on various natural language processing tasks. BERT is a transformer-based model that is trained on a massive amount of text data using a masked language modeling task, which requires the model to predict missing words in a sentence. In 2019, OpenAI released the Generative Pre-trained Transformer 2, GPT-2, model, a large-scale transformer-based language model with 1.5 billion parameters. GPT-2 can generate coherent and fluent text that is often difficult to distinguish from text written by humans. However, due to concerns about the potential misuse of the model, OpenAI initially only released a smaller version and later released the full version with certain restrictions. GPT-3, ChatGPT. In 2020, OpenAI released the GPT-3 model, which has 175 billion parameters and is currently the most significant and potent language model. GPT-3 can perform a wide range of natural language processing tasks, including text completion, question answering, and even writing coherent and fluent text from scratch. One of the most exciting applications of GPT-3 is ChatGPT, a chatbot built on top of the GPT-3 model. ChatGPT can hold conversations with users naturally and engagingly and has been praised for its ability to generate creative and humorous responses. Deep learning has come a long way since the development of the perceptron in the 1950s. From the earliest neural network models to the latest transformer-based language models, deep learning has transformed the field of artificial intelligence. It has enabled machines to learn and improve from experience in a previously impossible way. Today, deep learning is widely used in various applications, including image and speech recognition, natural language processing, autonomous vehicles, and drug discovery. Many of the biggest tech companies, such as Google, Facebook, and Microsoft, are investing heavily in deep learning research and development, and there is still much research to be done in the field. Despite the many advancements in deep learning, there are also concerns about the potential negative impacts of this technology, such as biased decision-making, job displacement, and the possible misuse of deep learning for malicious purposes. It will be essential to consider these ethical implications and ensure that deep learning is used to benefit humanity responsibly and ethically. Overall, deep learning has the potential to transform the way we live and work and to create a better future for all. As researchers continue to make breakthroughs in the field, it will be exciting to see what new applications and innovations are possible with this powerful technology. Thank you for watching.